This is a review of imaginary numbers. All of this none of this should be new, but it may have been forgotten or a little rusty, so that's why we need to go over what an imaginary number is. All right, can I have a definition? What is an imaginary number? Say it again. Something that has the square root of not just -1, but any negative number. All right, so an imaginary number is the square root of a negative number. Which goes against one of the great commandments of math. Thou shalt not square root a negative number. Except if you're allowed to use imaginaries, then you can. So this is what allows us to do square roots of negative numbers. Because up until this point, you try and type it into your calculator and you get error. Okay, you can't square root a negative number. But if you put your calculator in imaginary mode, then it can do it. Because then it's allowed to use imaginary numbers. Now, the most famous imaginary number is what? I. Okay, so I is the most famous imaginary number. It is defined as the square root of what number? -1. If you have I squared, that means you have two i's next to each other. I times I. That's what I squared means. And every two i's, every I times I, is regular -1. So that means if you have I cubed, that means you have I times I times I. Every two i's is worth -1. So these two i's are worth -1, which means you're really -1 times the leftover I, which is -I. I to the fourth. Well, that's going to be I times I times I times I. And again, every two i's is worth a -1. So you've got two pairs. So that would be -1 times another -1, which converts itself to be +1. So when you're doing high powers of I, as the power, you just group up, well, how many sets of 2 do I have? And every time I have a set of 2, it's worth a negative number. And so if you're doing like I to the 11th, well, you can think, okay, well, how many sets of 2 of those do I have? Okay, so I'm going to have a set of 2 that's worth -1, another set of 2 that's worth -1, another set. There are 5 sets of, each one of those -1s represents a set of 2 i's, an I squared. And then there's an I left over. So if you've got 5 -1s and then a single I at the end, is the answer going to be positive or negative? Why? Because there's 5 of them. There's an odd number of -1s, and we know that every 2 negatives make a positive. So if we have 5 negatives, then that's going to be -I. So you're allowed I to the 11th is equal to -I. So high powers of I, you're going to figure out how many pairs of I squareds you have, and then what you have left over. So in imaginary numbers, we can add, subtract, multiply, and divide. You're allowed to do all of those things to imaginary numbers. They go from easy to the most tricky. Adding is easy. So example 1, add. So you might have 8 plus 5i in parentheses added to -3 minus 7i in parentheses. When you add up the parts that don't have an I, and you add up the parts that do have an I. So you add up like terms. And so the answer to that is going to be 5, because that's 8 plus -3. And then 5 plus -7i is -2i. So you're adding up the like terms. They match up. 8 to 3 matches, and 5 to -7 matches. they get progressively trickier. Subtract. Let's take those same numbers. 8 plus 5i, subtract negative 3 minus 7i. This isn't supposed to be a trick, but it does trip some people up, because subtraction is really distributing in disguise. What do you have to distribute in a subtraction problem? The negative sign. And that, for some people, gets missed. It gets forgotten. So subtraction is really distributing. And when you distribute, you'll have 8 plus 5i, and when you distribute the negative, it becomes a positive 3, and it becomes a positive 7i. So subtracting is really distributing in disguise. And that becomes 11 plus 12i when you match up the like terms there. Number 3, multiply. Multiply is just FOIL in disguise. So you might have 8 plus 5i multiplied by negative 3 minus 7i. And that's just first, outside, inside, last. This one people usually get right. First is negative 24. That's an 8 and the negative 3. The outside terms are 8 and negative 7, so that's negative 56i. The inside terms, the 5 and the negative 3, that's negative 15i. The last part is something that people might switch around. 5 and negative 7i is negative 35, but the I is now squared. And the I squared that always comes at the end of FOIL is negative 1, because there's 2 i's there. And for every 2 i's, it's always negative 1. So this I squared right here is the same as having an extra negative 1. So this will become negative 24 minus 71 when you group those terms together. And then you have a negative 35 followed by a negative 1. That I squared becomes negative 1. So what happens to that 35 at the end is it becomes positive. So you've got negative 24 minus 71i, and then plus 35. So the trickiest part of FOIL is always the L part, the last part, where you're going to end up with I squared. And when you group those two together, 35 and 24, you'll end up with 11 minus 71i. Does the order matter? The I part should always come last. Yep, always come second. Okay, we need another multiplication one. Because I need to introduce a vocabulary word. And I need to introduce the vocabulary word of a conjugate. Multiply with conjugate. C-O-N-J-U-G-A-T-E. Multiply with the conjugate. Yeah. Now, conjugate is one of those vocab words you need to know because it's going to show up on an open quiz and test and stuff. You might have the number, what have we been working with? 8 plus 5i. The conjugate with 8 plus 5i is 8 minus 5i. All you do is change the I part. You don't change the 8. You don't change the first part. You only change the sign of the second part. Okay, multiply with a conjugate. So anytime the word conjugate shows up, that means you're changing the imaginary part, and then you're going to do FOIL after that. So that'll be 64 minus 40i plus 40i minus 25i squared. If you multiply with a conjugate correctly, the center two terms will always cancel out. A conjugate will always result in cancellation of the middle two terms. It will also always result in an I squared at the end. So after you cancel, and turn your I squared into -1, you're going to have 64 minus 25 with a -1, which becomes 64 plus 25, which then becomes 89. So multiplying with a conjugate results in a couple things. It always results in cancellation. It always results in an I squared at the end, and the ultimate answer will always be a whole number. So that's still all in number 3 in multiplication. Then that leads us to division. Division is always with a conjugate also. So when you divide, imaginary numbers look like this. 8 plus 5i divided by, so it's going to look like a fraction. Let's say 5 plus 4i. That's the way division looks. The conjugate is always applied to the denominator. Denominator is the most important part, just like when we have domain. So the conjugate is applied to the denominator. So around 5 plus 4i, I bring the conjugate of 5 minus 4i. That same conjugate is applied to the numerator as well. You don't do different conjugates. You use the conjugate for the bottom, and then it also gets multiplied to the top. So this becomes a FOIL problem. Division is always done foiling by the conjugate. So you FOIL out the top. You're going to get 40 plus minus 32i plus 25i minus 20i squared. You'll always get the I squared at the end of a FOIL problem. The bottom will become 25 minus 20i plus 20i minus 16i squared. And there's that I squared at the end of a FOIL problem again. When I clean this up, the 20's in the bottom cancel each other out, so I have a 20i minus and a 20i plus. And I have an I squared at the end of both the top and the bottom. Those don't cancel each other out. They just each turn into a -1. So I'm going to have 40 minus 7i, which is the combination of -32 and 25, and then minus the 20 with a -1. And the bottom is the 25 minus a 16, also with the -1. So those I squareds at the end both turn into -1. Again, they don't cancel each other out, but they change their number to positive. So the 20 turns into positive, and the 16 turns into positive. So your overall answer combines the 40 from the front and the 20 from the back to be 60. And then the bottom turns out to be 41. So you get 60 minus 7i over the whole number 41.